next moment, sir, dear friends. Good afternoon all. I am Abhiram Kumar, currently pursuing my first year undergraduation in BSc Geology. First of all, it is an honor to share a platform with such an amazing group of audience, especially Jagiran sir. So in this session, I plan to say a few words about the mountain ranges and their formations, especially those in India. Before that, we have to know what mountains are. A mountain is a large terrain feature that rises more or less abruptly from surrounding levels. That is, it is a landform with higher elevation than the surrounding ground level. Now, a mountain range is a series of mountains or parallel ridges which will be closely packed. They are mostly composed of tectonically deformed rocks. I hope even some of you might have visited some mountains and you can clearly understand that elevation change and the climate change due to that elevation. Here it is a photo of major mountain belts in the world. We can notice that many of the belts are in the coastal regions, the North American caldera, the Appalachians, but some like the Himalayas are in the plains. So let's move on. For the clear understanding about the mountain ranges, we have to know the formation and changes of them. That is the evolution of the mountains. So the formation of not only mountain ranges, but also almost all physical features are closely related to the internal structure of the Earth. As we all know, the Earth is comprised of three major layers. We have a rigid rocky crust, then we have mantle, of which upper mantle is rocky, and an almost molten lower mantle. Then we have a liquid outer core and a solid inner core. We know that if this change in different layers, the property change in different layers, due to this change, a vast amount of energy is released in the form of waves, and it causes movement of lithospheric plates or tectonic plates, leading to the formation of various physical features, including the mountains. We can see in this figure the mantle convection, which will eventually cause the movement of plates. So let's move on to the types of mountains. First of all, it's volcanic mountains. Mountains can be formed in three ways. The first one is volcanic mountains. It is formed by the movement of tectonic plates, which create volcanoes along the plate boundaries that that create and eventually form mountains. A volcanic arc is a structure in which it will be formed on the ridge. Here we can see that a oceanic crust and a continental crust is collided, and ridge will form along the subduction fault. So the next one is the fold mountains, which are formed when the plates collide or undergo subduction. That time, the plates tend to buckle and fold, forming mountains. Most of the major continental mountain ranges, like the Balkan, the Jura, are found this way. Here we can see that two continental crusts are collided. Next is block mountains. Here we have a fault block raised or tilted. Block mountains can be formed by the by the raising or tilting of the fault blocks. Here we can see the middle one is the fault block. Block mountains are formed by its lifting or tilting. Here the higher blocks are called horse, and the troughs are called gravels. So let's move on to the mountain ranges in India. We have uh, or first we have the Himalayas. Himalayas are here we have in the northern side of our country. Then we have the Aravalli range, almost here. Then we have the Vindhya Satura. Then we have the Western Ghats. Then we have the Eastern Ghats. So let's move on to the Himalayas. So the Himalayas stretch 2,900 kilometers along the border between India and Tibet. So let's move on to the formation of Himalayas. Here we can see that Himalayas are usually the new mountains which began to form between 40 and 50 million years ago, when the Indian plate and the Eurasian plate collided. As the both plates are about same rock density, one couldn't be subjected. So the pressure from both the plate can only be relieved by the upward thrusting and thereby form the Himalayas. So let's look at it in detail. So about 225 million years ago, India was an isolated island. Can you believe it? About 225 million years ago, India was an isolated island separated by Pacific Ocean from the Asian continent. During the breaking of Pangaea about 200 million years ago, India began to move northward. Remember, it was not a sudden movement. The movement rate was just 9 meters a century, even though when compared to geologic time, it is a sudden movement. About 40 to 50 million years ago, India collided with the Asian continent and its advancement was slowed to half. This was marked as the birth of Himalayas. The Himalayas and the Tibetan plateaus to the north rose very quickly. In just 50 million years, in just 50 million years, remember it's 50 million years, Mount Everest with height more than 9 kilometers was formed. Now also the Himalayas are rising at a rate about 1 centimeter per year, which when we calculate in a million years, the Himalayas will rise to a height of 10 kilometers from where it is now. So as the plates move forward, it will result in the domino effects, which will eventually cause major earthquakes. When we when we look into the previous earthquakes, we can see that many of the disastrous earthquakes occurred in the country happened in the foothills of the Himalayan regions, especially in Assam and Bihar. So let's talk about the significance or importance of the Himalayas. Firstly, they influence the climate of the country in a major way. It acts as a natural barrier then. Uh, its significant presence is always advantage to the Indian defense system. Here we can see that China can't. Sir, am I audible?
Yeah, you are. Abhiram, you are audible. Okay. Go ahead. Go ahead.
Yeah, due to this natural barrier formed Himalayan rivers, which is the Kansas and the Yamuna, and so on, they all make the North Indian plains fertile and suitable for agriculture. So many of the mineral deposits like the coals, lead, copper, zinc, nickel, etc., are found in the Himalayan mountain ranges. So let's move on to the Aravalli ranges. That's all about Himalayas. Then let's move to the Aravalli ranges. They are one of the oldest tectonic mountains in the world. They originate in Gujarat and extend till Haryana. They have a main extent of 800 kilometers. They are old fold mountains. Remember, they are old fold mountains, and rocks collected from these mountains dated back more than 2 billion years old, which means probably the Aravalli ranges will be more older than the rocks we collected. But unlike other fold mountains, they have less elevation. It is due to the weathering and erosion happen in these mountain ranges. They are mainly made up of lava, igneous, and metamorphic rocks. So, speaking of the significance, as like they also act as a barrier, but between the fertile plains in the east and sandy desert in the west. So, they almost prevent the extreme hot temperature from the deserted regions to cross to the western fertile plains and thereby saving agricultural lands. It is rich in biodiversity and it acts as a groundwater recharge zone. During monsoons, it provides it, pro- it provides as a barrier, and monsoon clouds move eastward towards Shimla and thus recharging the sub-Himalayan rivers and feeding North Indian plains. So that's all about the Aravalli ranges. It is very much significant to our agricultural sector in northern India. So next we'll move on to the Vindhya ranges. The Vindhya ranges are very old mountain range in central India. Earlier, we got earliest known multicellular fossil of eukaryote from there. It dated back to 1.6 to 1.7 billion years. It is less plugged and smaller in size. Then we know that it actually form a division between the Indo-Gangetic plain and the Deccan region. It is a non-tectonic mountain formed mainly by the downward faulting of the Narmada Rift Valley to its south. It is much younger than the Aravallis and Satpura hills. It is made up of older Proterozoic rocks. It's made up of older Proterozoic rocks. They are cut across by kimberlite pipes, which are diamond deposits. They are known by local names such as Panna, Kaimur, Reva, etc. They rise from the Narmada Rift Valley in the form of steep, sharp slopes called the escarpments. These escarpments are well developed in the Kaimur and Panna regions. So speaking of the significance of the Vindhya ranges, They restrict the path of winds, making the area quite inhospitable and rough. So the climate will be rough there because they block the path of winds. The different slopes in Vindhya range are drained by the tributaries of Ganges towards the north and Narmada in the south. These ranges have huge sandstone reserves. I think the Buddhist stupa at the Sanji stupa, the sandstone used in Sanji stupa was collected from here. A number of tributaries of Ganga, Yamuna originate from the Vindhyas. The Vindhyan supergroup is one of the largest and thickest sedimentary successions in the world. So that's all about the Vindhya ranges. Then we have the Satpura ranges. The Satpura range is a combination of Satpura, Mahadev, and Maikala hills. Satpura hills are tectonic mountains formed about 1.6 billion years ago as a result of the folding and structural activity. They are a host landform. They run for a distance of about 900 kilometers. The plateau has the drainage system of Narmada and Son, hence it has the drainage into the Bay of it has drainage into the Bay of Bengal as well as the Arabian Sea. These are mostly situated in the states of Madhya Pradesh and Chhattisgarh as we look in the map. These hills are rich in bauxite due to the presence of Gondwana rocks. So this is the horse and graben structure, as I told. It's a blocky mountains. So speaking of the significance, although it is economically poor, the Satpura ranges contain some work manganese and coal deposits there. It's largely forested and have many valuable teak stands which we use as furniture in many high buildings. In the upper Vainkana and Pench valleys of Mahadev Hills, there is some agriculture, most commonly jhum cultivation, which is slash and burn cultivation. So next we move on to the Western Ghats. Here we can see that we see the formation. The Western Ghats have been formed by the subduction of the Arabian Basin and tilting of the peninsula in east and northeast during Himalayan uplift. Thus, it bears the look of block mountains in the west and the slope appears to be escarpments and stairway formation. Thus, along the west coast, they look like suspects. The Western Ghats has three sections: the Northwestern Ghats, Middle Sahyadri, Southern section. Here we can see the Northwestern Ghats, the map. Uh, the Northwestern Ghats is located between the Tapi Valley and the 16-degree north latitude. It has a basaltic lava cover. It has a basaltic lava cover. The highest point is Kalsubai. It is highly rugged and dissected by rivers. The northern section of the Ghats, from Tapi Valley to a little north of Goa, is made of Deccan tracts. So, moving on to the middle Sahyadri, it runs from 16-degree north latitude up to Nilgiri Hills. This part is made of granites and gneisses. This area is covered with dense forest. The western scarp is considerably dissected by headward erosion of the west flowing streams. So, the last and southern section. The southern part of the Western Ghats is separated from the main Sahyadri range by Palakkad Gap. Have anyone been to Valaya? There we can see this gap, Palakkad Gap. It is also called the Southern Mountain Complex. The southern section of the southern section of the Western Ghats is also known as the Southern Mountain Complex. The high ranges terminate abruptly on either side of this gap. Palakkad Gap is a rift valley. This gap is used by a number of roads and railway lines to connect the plains of Tamil Nadu with the coastal plains of Kerala. It is through this gap the moist-bearing clouds of the southwest monsoon can penetrate some distance inland, bringing rain to the Mysore region. Speaking of the significance of the Western Ghats, they feature a large number of perennial rivers like the Godavari, Krishna, and Kaveri. They are major eastward flowing rivers. The mountains of the Western Ghats influence the Indian monsoon weather patterns that mediate the warm tropical climate of the region. Thus, the Western Ghats play a major role in carbon dioxide absorption and hence have an important role in climate change. They are rich in iron, manganese, and bauxite ores. The forests of Western Ghats are important source of timber and support a large number of forest-based industries. At least 325 globally threatened IUCN red data list species occur in the Western Ghats. IUCN red data list is the list of globally threatened species, including plants and animals. There are a number of tourist centers that have sprung up in the Western Ghats. Example like Ooty, Tekadi. I hope many of you have been there. So moving into the Eastern Ghats, it is in the eastern side of the, I mean, around in the eastern side of Kerala.
Peninsula.
The Eastern Ghats are much older than Western Ghats and have a complex geologic history related to the assembly and breakup of the ancient supercontinent of Rodinia and the assembly of the Gondwana supercontinent. Geologically, they are late Archean to Proterozoic cold mountains and the younger contemporary to Aravalli. Presently, they are highly dissected, which means they are not continuous, fragmented and appear as hills of denudation running roughly along the eastern coast. The Eparchian unconformity of the Tirumala Hills is a major discontinuity of stratigraphic significance that represent an extensive period of erosion and dawn deposition. It is seen at the steep natural slopes, road cuts, and ravines in the Tirumala Ghat roads in Chittoor district of Andhra Pradesh. These eastern Ghats have an average elevation of 150 to 300 meters, which are very much comparatively lower than the other mountain ranges. The eastern Ghats are made up of charnakites, granite gneisses, chondrites, metamorphic gneiss, and quartzite rock formations.
Abhiram, I think if it would be good if you conclude because you have taken a lot of time.
Sir, I'm concluding, sir. Sorry. So, speaking of the significance, it plays an important role in modulating climate, fostering biodiversity, providing sustenance, and storing energy in trees. Many rare animal and plant species are there, so we have to protect. It is seen that about 16% of the forest area have been destroyed in the past 100 years. So that's all about. Thank you for your patience. If it had been over time, extremely sorry.
It's okay, Abhiram. Abhiram, can you? I know it's less. Your data is you have network issues. Can you switch on your camera?
Sir, let me check.
Yeah.
Sir, am I visible?
Wait. Yeah, you are visible. Sir.
Okay, Abhiram. Abhiram, it was a good presentation, but the topic that you took was a huge topic. Because if you notice the other two titles of the earlier presenters, one had taken coral reefs and their significance. The other had taken groundwater contamination. Whereas you have taken mountains and you can go endlessly for one day talking about mountains, and it's very hard to handle. Anyway, you took that challenge and you tried to do justice to that, and you have done it within the time. Why I stopped you is because we didn't give this liberty to the other students because we told everyone 15 minutes, and this is something you need to take care. You need to think about the time, put everything within that time, and be as concise as possible. So that is it. So why did you take this topic, mountain ranges? Was it a suggestion from your teachers, or you yourself decided to take this?
So actually, it was formed as a discussion from me and Teresa.
Hmm. Okay, okay. Anyway, mountains definitely is a good topic. I don't want to say that it's not a good topic, but it requires a lot of experience to put this particular presentation within 15 minutes. So just tell me, because you mentioned about almost all mountain systems in the country. So when you look at these different mountain systems, what is the major differences that you notice between Himalayas and the other mountain systems?
So the Himalayas are actually growing.
Okay,
Then most Himalayas have almost cold climates. So that's what
okay,
I.
right, right. Because you mentioned while talking about Aravalli that you find very old rocks there, but the elevation is very less compared to Himalayas,
Yes, sir.
right? Because you find Archean rocks stretching up to 2000 million years in the Aravalli. Whereas in the Himalayas, if you go to the Himalayas, you'll not get rocks more than 100 million years, except in the core region. All peripheral region, you get young mountains, young rocks. So that is the difference. The age
Oh,
the other mountains are all very old, residual mountains, we say. You could have also introduced the classification of mountain systems in one slide. That would have given more clarity to whatever you said. And in when you talked about Western Ghats, you talked about subduction. Can you tell me how Western Ghats is related to subduction? Just a curiosity question.
Sir, I hope it was the subduction of the Arabian Sea. Was
No, Abhiram.
Uh,
Abhiram, while talking, while